Hello everyone, my name is Dennis and I'm the author of Chromatone, the visual music language. And also I'm the developer behind the Chromatone.center, the interactive portal that I'm developing for a couple of years with Vue, Vid and all amazing web technologies that I try to combine into something very interactive, playable, fun and easy to explore, yet educational and really helpful for musicians in real life. So just immediately when you open the website, the Chromatone.center, you have virtual keyboard on your desktop, or you can plug in any MIDI controller, and this website is MIDI enabled, and you have these synthesizers with even some options to choose from, and yeah, it can fit your needs, and you can filter MIDI channels and many more, and have this metronome. Yeah, you can control it just with spacebar. So yeah, and also you can enable your audio input and have your audio analyzed, and you can see the notes like ooh. Yeah, so I'm climbed up to the A note, and you can definitely see this and jam with your instrument to these same notes. So this can be very, ooh. Yeah, so I play A and sing E just by visual representation, and yeah, that's kind of powerful thing, because yeah, you can just go to practice and a huge theory section and all that, but today I want to share with you some more deep insights into the system, because I want to share you some code, and that's all about open source code and open source libraries that I use. So if you go to the contact page, you can go to Chromatone GitHub organization that has all the code sourced there, so you can see all the projects that are developed under this Chromatone system, and the main one is Chromatone.center itself. So this is a VidPress website with many web technologies used, and the list grows and grows, and we have many amazing libraries that enable this live audio analyzing, this MIDI processing, and also the synthesizers. And yeah, you can just see, I can just show you how you can understand. So the website structure in short, so we have this index.md, and that is just this. So this is a Vue component Chroma flower that has all this interactivity encompassed, and I just put it into a markdown file and have this text just from a markdown that is published on this repository under content. Yeah, here is this index.md file. Yeah, so here's the same text, and if you go to code, yeah, you can see these same components. And these components are auto-imported, but we can go and build more transparent things. So today I want to dive deeper into code and explore what can we build with new tool that I'm using, this elementary elementary audio, elementary.audio. This thing should be, yes. So this is very nice thing, and fun thing is that this web audio library, but they don't have any sounds on here to explore, and even examples are just almost useless until you web app examples. Yeah, you should dive deeper to find out this one, and I've already shown it in the previous streams, and I really love the sound and the ability to synchronize it with visuals. And yeah, I'm kind of deep into this already, so let's go into this already. Okay, I have this same repository here in my VS Code, and there are these main folders that have the components that are auto-imported, the content that is just markdown files, mostly the database with the YAML files about all the interesting things in music, the theme about how this website just looks and works internally, and the use, that is all the logics that is just extracted and can be used as a separate library, just a JavaScript package, use-chromatone. So anyone can just import any of these functions. So it can just be your mouse, MIDI devices, it can be colors, it can be audio itself, audio input, audio analysis, tuners, sequencers, even piano. So many things are just available to anyone who wants to build their own, JavaScript and music web apps, basically. Yeah, and now I'm kind of deep into this new approach to the whole sound system, because Elementary is a beast in itself. It's very powerful thing, but it's kind of low level, and I have to construct kind of audio system, audio engine for the website. And now it is based in practice in MIDI in synth section. So it has many folders there, and it all starts with just the markdown file. So let's go and let's start a development server and look at this page. So we can go to Elementary Synth just by this. So practice MIDI Elementary Synth, and once I hit a button, this all will come to life. Now it's kinda in suspended mode, and just let's check this out. So how it's working here. We have this text, so modular synth, and it's very fast to reload. Okay, well, I can see it right there. So this is hot module replaced. It just jumps a little because we have this define client component. So this LM audio is loaded on the client only, and the server doesn't render it, and this saves us from many problems importing audio and window when we are building this website, because every page is a separate HTML file, self-sufficient, but yeah, they are all interconnected in a very nice and interactive thing. So you can browse any page from the beginning. It will be SEO optimized, it will be nicely rendered, but then you can browse all these pages without real page reloads, and it's kind of fast and yeah, really beautiful. Yeah, you can go in any direction and have instant interactivity. Okay, but yeah, now we have our development server, and then we go to this LM audio. Okay, so it's coming from audio, LM audio. So this is the component that is orchestrating everything, and I could just use it in a markdown, and further down the development process, I will have all these components just separately important and use it like in more diverse way. But now I'm just developing these modules to play with, and it gets into this modular structure. So these could be like separate experiments and separate instruments, and they will become these, but now we can just see them as modules right inside this folder. So it encompasses all my elementary experiments, so it will be like very easy to refactor and change many things that are not too easy to change if your code is already scattered around this structure. Okay, and I want to share the idea of having this audio engine for all of these modules. So every single module of these imports something. It imports this use audio function. So if just we go to main synth view, that's component that we load when we load the audio LM audio. So main synth, yes, this component is loaded, and we use use-synth. So this is composable API from Vue 3. So here's just the component code, the template, and just that much of a JavaScript and basically TypeScript, but it doesn't matter in this case. And it's just the colors to be calculated here, but all the MIDI controls, voices, and functions to play the note, the actual notes, come from other places, and this use-synth comes from use-synth. So let's go to use-synth, and yeah, here we have this audio, use audio. So every of these composables will at some moment use the audio, and this is the center of all that. But yeah, it's modularized, and yeah, it's this all the code of the synth for now. But you can see that we have the audio, the UI, some helpers, and also the voices as a different package. But let's look at the use audio for now. So we are importing this constant, which is shallow reactive, so it doesn't affect the objects that are lower than one level. So they stay not a proxy, but stay in original form, and this is safe for our contacts and core and audio nodes, and everything is here. I actually tried to separate these layers in a separate reactive layer, reactive variable, but I get some weird glitches, and this setup works, and I want to share it and fix that. This really works in this situation. So we have initiating and initiated flags. I couldn't make it better for this function to be reusable many times, so you can just use audio and get the same object that is just one object that's not constructed every time. It's just the same object, but it will have these nodes populated with the correct contacts and nodes, and not repopulated if you have it twice or many times. Okay, and also there is meters, scopes, and FFTs that are just collected from all the layers, and that's kind of interesting approach. So use audio is calls init, and it's async, and then if it's initiated, it's okay. If it's not initiated, so it's kind of two flags. So initiated thing. Yeah, so this is second stage, and we start watching audio layers and start rendering whenever the layers change. And what is render? We will see it. And also we have this core event listeners that get us and populate the information about the for meters. So every meter that we set in a graph, in audio graph, will be in this reactive variable, and yeah, it will be just accessible in any place of the application by importing these meters and scopes and FFTs. And this is I like this system It's kind of refined. I used many approaches and find it very nice. And there's the render function. It's kind of reacting to the change of layers. So it's supposed that you don't run the render function by yourself, but I'm considering running it concisely, because this reactivity can get tricky when you have many layers doing something at the same time. But with render function, then we can just be more precise about it. So this render function is also the initiating function, so we should be so it's kind of messy. Maybe I will just clean it up more, but now it's just, safe. So it will continue running your audio context, and it will initiate all the audio just on the first touch. Yeah, so I just have the first touch, and I have immediately everything running as it's supposed. And yeah, we've heard these sounds now, and hope you like them, because this is the synthesizer that's comprised with a kind of sawtooth wave, but smoothed out, and also a noise oscillator and a ping pong delay. Yeah, and it can be very nice to play with. I like the expressiveness and the visuals, but let's stay in the loop and just check the audio. So we have this stereo, which has our first meter. So it's just outputting us the sample rate. So you can see it just right there, sample rate. No, it's main, but it should be time. But if I say time, for example, here I will say time. Again, so yeah, sample rate is here, and I get it just from meters, because all these things are related to time, and I just have it there. Okay, I will show how it's done internally later. But it's basically silent, because we multiply it by 0, and this is 0. So this is just the beginning of the construction of our audio graph. Then what we do is, and this can be really out of this render function, but I prefer to keep everything inside, so it will be more easy to understand. Okay, so then we go through layers, and for each layer we have the signal. So this is the idea of a layer. So it's kind of channel thing. Maybe I will add panning here, and it's kind of easy to add, and we can go just from here. So pannings may be there, so it'd be number. Yeah, so pan can be set, and yeah, but the main thing is signal. So signal is an array, because it's a stereo or multi-channel thing, and it will have either a number or a LM audio node. And okay, this node will be so this for signal. So for any channel, for every channel in a signal in these layers, we will update this. So we will set signal is, and what do we have? We have the volume of this layer set with mute and volume, so it will be like reactive to mute. And we have this layer signal. So So for stereo signal, we have two signals, left and right, that are just attenuated with volume and mute. This is just everything, all the audio system to have this signal. And then we have this compensated, limited, soft limited sum of all these layers. So we just have stereo channel. So this stereo channel, this will be updated. This won't be the same, but we will have it added with this signal that we composed here, and we will have this tangent function that will just safely clip it to 1, so it won't be too loud, it won't add up to infinity. In some cases it may do this with some delays, reverbs, and anything that will go out of control here, and it can be easily done, and I've been to places. Okay, but then what we do is we go to audio core render. This is the main function. The core is the elementary core, and it's rendering this stereo 1 and stereo 2, and yeah, we have this main FFT going right from there. So it's big and very precise FFT, and yeah, we see this on this graph right there, and yeah, it's just doing its job just because we defined this FFT here, and it's just spit out in the event loop. Okay, yeah, init function is just having the audio context, the core from web render, from elementary, and we have this initialized with inputs and outputs and just connected to destination. That's it. So this audio setup works fine, and even having these FFTs with SVG, so imagine 2000 SVG rectangles with rounded corners, drawing this interactive graphics with kind of nice performance. Yeah, it can get tricky for lower powered devices, and I'm really into rebuilding this with web GPUs and web GPU or just WebGL shaders. That's kind of very powerful thing, because I have already this here and GPU shaders, so this is very robust and yeah, very reactive, and it looks fabulous on dark screens. And yeah, you see there is no lag, and it's no lag even for underpowered devices, because GPUs are fast. Yeah, this is not optimized, and let's just continue with bright screen for now. So here's the overview of the basis of the web audio engine for this website. But yeah, it's not complete. I don't feel that having these layers here is final structure, but yeah, now I like that if we try to add change any of the layers that aren't here, so the TypeScript will say, what, another layer? May you declare it first. And for my website it won't be like this. You will be able to add layers from any place of the web app. But yeah, for now it's like this, because it's not the only thing I'm building, because this whole synth is still needs some attention, and not only the synth, because yeah, it's kind of not very polished, but yeah, you can see this. And I want to show you how I built how I see this modular structure going into be like a a place for everyone to create your own audio modules to play with, this like playground. Because all you need, you just import audio and just have a layer and then render, hit render. So let's see where we have the render here, or layer, let's say layer. Yeah, so this is where the things happen. So we watch the voices and the controls, and then we set the synth to this and then render. Yeah, and what do you build outside of this is like creative decisions, but it's not only creative decisions, these are engineering decisions. And I like this use UI thing that can be very, very useful for many new modules to be constructed. And it's all starting with parameters, with just a JSON file really. And I like this to be just a separate JSON file because it's kind of more strict and more transparent and maybe parsed in many ways. And yeah, it's kind of separate layer when you think about the parameters that you want to control. And for example, and everything is kind of automatic. So let's think about it. So for oscillator there is a gain, and also there is a parameter that controls I believe the resonance. Let's look at main synth, at use synth. So there is one thing that I like. Yeah, immediately we have errors, so everything TypeScript is working its way quite fine. Yeah, so this multiply for and frequency. So low pass filter will have these multiples of the frequency. So this is cutoff frequency, and it is just precisely 4 times the frequency. So it just operates relatively to the main frequency of a voice. And I would like to have this. One moment. Okay, and I will have, and I would like to have this controlled this in the same way as these other CV voltages. So oscillator cutoff will be the same parameter, which will have value of 4. That's default value. Minimum value will be 0. Immediately it just appears there. Okay, maximum will be 8, and step will be 1. So we will or 0.5, like this. So yeah, there is this cutoff. I will update. Not a number. Why not a number? Cutoff value. Let's run. So use synth. I know. It may be not knowing. Okay, let's go to main synth and have this. Groups. Yeah, so a group title and controls. Oscillator cutoff. It should be working fine. I don't know why we're getting let's say cut. Yeah, it just needed to update, so we can control it. Okay, and this should Now it doesn't affect the sound, of course, because it's not connected. We just created this parameter, but it's immediately we can immediately start using it because we have this use UI that just reacts and constructs the parameters for us, and it outputs a controls list. So for every param there will be a control that we actually control. So for this main synth we control here we controls, this will be oscillator and cut off, just cut. Let's say cut off back. What? Somehow cut off. And if more, I don't know why this is happening. Let's say it's like this. Yeah, I don't know why, but okay. Let's go here. So this will be what we control, and the groups are the groups. So oscillator, noise, FX, and main are getting from this main oscillator. So yeah, this is automatic, and I like how it works, and I hope it's flexible enough to stay with this system, because these are kind of all the knobs on a board, and we have only like a flat board with groups, so no 3D, nothing this too much, but let's see. For now it's just like this, and okay, and let's just look at this tools, use UI, and here are the params that are just parsed from the JSON, and we have them here, and there's the title, and then we have this use clamp and use storage from use, and we have these amazing refs that will be kind of saved into local storage and have the max, and they're clamped with minimum and maximum with inside code, so it's kind of safe. And then we have groups of them, and the controls are just reactive controls. This object is just reactive with them, and groups are just those that are grouped, and that's all that we have there. And the CVs, of course, CV is web so elementary audio node that has this smooth, kind of fast smooth, that is lconst wrapped around. Yeah, it has its title and it has its value, and this is reactive, so we watch controls and update these CVs. So CVs are reactive audio nodes for elementary, and they are kind of recreated again, but we have this key, so it will be like knowing that it is the same const, and it will be smooth and interpolated, fast and reliable, no clicks and pops, until you have a video recording and audio and all that. So sometimes you can have it, but yeah. So now I can play. Okay, I can have all the parameters, like even the release, you see? Yeah, it's I like how it works, and it's nicely interactive, and it's just that easy. So, and this is reusable, very reusable, and I already use it here for BPM, I believe. I already use it here, so this is the time. But yeah, I changed the BPM, and the BPM here changes also because it's a CV. Yeah, so kind of audio analogies in programming, and that's I totally like it. And okay, let's get back to the synth. And yeah, have this CV actually working. So I just can put here this CV, and it will be oscillator cut off like this. So now yeah, that's how it's going. Yeah, that's a sharp saw. So yeah, this is how it's going. So just this line of code, and yeah, let's make it a little more pretty with this. Yeah, like this. So this is all we need, because this is a saw with a frequency, and then we have a low pass and this ADSR, and everything here is controlled, so no numbers left here. Yeah, this number is left here. So I believe this is for low pass, this is Q. So let's say we have the Q. Okay, maybe we can just have this filter cut off, cut Q. Okay, let's have cut off, cut Q. And it can be quite expressive. So we have 1.1 as a first, as a 0, okay, and let's have a 10, and let's have smaller steps like this. Okay, and we have this here, CV cut Q. Yeah, we got it here. So yeah, we got some distortion, and you can just see it because of this spectrogram just going out of, out of this reach, and this is just 1 by 1, so it's out of 1. But yeah, our signal is squashed with this, and it's kind of safe, but so we can drive it very, very loud, but yeah, it can be quite unpleasant sounds. Yeah, I like this half steps because it's just more expressive, and maybe this cut Q should be that high, like 5 will be okay. Yeah, 5 is okay. Yeah, and 0 is too low for the cut off, so cut off will be 1 at minimum. Yeah, it's almost making our sawtooth sound like a sine wave, just 2 harmonics barely going through. Yeah, and if we increase it, you see all these peaks. Are there, kind of bright sound. Yeah, I like it, and it looks like a real now it looks like a more, yeah, like a saw wave. Yeah, okay. So this is this system with params. I really like this, use UI and CV. Maybe it can be use CV, but use UI is fine because it's used for UI. and these are view reactive things. Oh, and also we have this noise bandpass, and this is the Q of the bandpass. This is very, very high, but this makes this noise tonal. So let's hear. Like this. Yeah, and I immediately see the problem with the groups. So it's already too many. It's more than 7. It's 7. And humans don't perceive groups more than 7, so I couldn't add any parameter here. But maybe it's fine for now. Maybe later I think I will create a simple ADSR component that will be encompassing these 4 parameters into kind of one, but more complex, and it can lower the pressure on our brains. Let's add one more. This control over this Q for the synth. So here will be noise, just band Q. So band Q will be, so value is just 50, minimum value is just 0, and maximum value will be 100 this time. And let's say step will be 0.1. So this band Q is there, and let's go to here and have a, so bandpass has the same frequency, so this noise and this Q, and let's see, say CV noise band Q. Yeah, so yeah, this doesn't have any frequency because there's just band passing everything, but now we increase, and I like how it's just immediately there and immediately interactive without any reloads, and yeah, the time still goes, and yeah, that's kind of beautiful thing. I really like it. Okay, let's see how it goes next. So we have these 2 structures that create oscillator and noise. So oscillator is a saw that is going through a low pass filter through ADSR, like multiplied by ADSR, also multiplied by oscillator gain, and also affected by voice velocity. Yeah, this is velocity sensitive. I just don't have a velocity sensitive control just right here connected, but it definitely will work. And also noise that works in similar fashion, so this is multiplied, and this can be reused. I can put it right there, so it will just affect both of them. Really, it can be done like this, but now I just have it like right there. Okay, and we just add them up, and let's extract this feature. So I want to share this working process. So yeah, multiply, we will multiply this sum up by this amount, and so we don't need this here. Yes, velocity is the same for both. Yeah, this will work just the same. Yeah, and if I reload, it will stay the same, and I like that. All these parameters will be just stored in the local storage, and just with one line of code, and no lines of code basically, if you use UI function and use it. Yeah, this is good, and we can also have a like octave multiplier here and use many other things in our um, work. But the thing is, there are too many knobs, and I need to do something about it. Okay, we have these voices, and these are generated by generate voice. So generate voice is used here in a poly function. So another function that's having the voices list, and then it multiplies main volume, and also have this voice count. Yeah, so we have this attenuated volume by the number of voices. That's kind of 8. So it can be much simpler, but yeah, it's fine. The thing is that we have this for all. We map through all the voices for voice list this reactive. So it comes from use voices. Let's get there. So these are 8 voices that are used. So every one of them has a key, has a gate, has a MIDI number and a velocity. And when I put this, I put gate to 1 and velocity high velocity, and when I go back, low velocity, and gate is 0. Use voices generates this reactive object that has this list. So voices list will have this array that will be used, that we are circling, like cycling, and next and overflow the numbers that we need to navigate. And you see cycle the notes, so every time new singer, but then there are 8 of them. And overflow is needed when we have 8 voices already, and I had very nice overloads and infinite loops, but now we're safe. And we have this cycle node that takes a number, a MIDI number, and a velocity of this MIDI number. And if there is velocity, this means that this is node on event. So we will cycle through list, and if we cycle too much, we will break the loop, and then we set the parameters of a next voice to this MIDI and velocity, and if not, we just set the gate to 0. That's all. And there is a stop all function just to be safe if something hangs, but that's all. So this voices object has this list that's just changed by the incoming nodes that are cycled. So cycle node and voices are the things, and we just import them here. And yeah, cycle node is the thing that we run when a MIDI node is coming. So this is my use-chromatone function, use MIDI, and you have the MIDI and MIDI node. That's also a reactive thing. And we can react to it and cycle through nodes and have the velocities of these nodes too. And yeah, it just works, because even if you use just your computer keyboard, this will be MIDI node events here also, like changing reactively, but all the changes will be affected here. So cycle node, and yeah, gen voice is very important thing here, because when we cycle nodes, we kind of update the voices. This is the only thing is happening here. So we just update the voice, and then we let me see. We watch voices, and then we have this ping pong. So every time voices change, we construct the new layer, and it should be just a little different maybe it should check if there is an object that will just set the parameters, but it's not big difference because of this keys and everything that we use. So new layer will be synth will be updated with ping pong, with elementary scope synth that will be outputted here when we play. Scope, this is the scope that we see, this buffer with the size of 520 to 512, and the poly function with the list of voices. So this is what happening. So we're running this ping pong because it makes our signal stereo and also makes these effects, and I hope to put the effects out of this layer. So this is just a synthesizer, and then will be these effects, but I will think about it because I need to implement this send and wet and dry, all these parameters, because it shouldn't be like global for everything. It should be kind of versatile, and yeah, but for now it's just an effect of a synthesizer and it lives here. So ping pong, we have this delay that is just a little different for left and right channels, because these are array of twos, these are just stereo filled with null and mapped. So we, for two of these channels, we have elementary add, and we add the parameter that we the audio that is already there, and just multiply it and add some delays there, and we attenuate them with this CV. Yeah, we can change the feedback here. I believe it's feedback, length and where is it? Here, length and x. Feedback. Yeah, feedback can be changed. Do we want to play with it like this? Let's do this. Okay. So I will change it. Oh no, let's keep it like this. The main thing is that we have this ping pong outputting the results of these x, and these x is incoming mono signal, and poly is outputting just a mono signal, just this node, and then this node has all the sounds from all the voices, because now we add for every voice we will have output the voice that is generated by gen voice. And so with this gen voice, yes, so this will be the sound. So this will be multiplied by the velocity and sum of our two oscillator and noise. This is the structure of the synth, and I like to share it because it's kind of work in progress. I don't feel like it's finished, because there may be more layers of abstraction to make this more modular, and these 8 voices can be like voice banks that maybe several of them running different, different these oscillators, and these can be useful for huge polyphony, or I don't know. It's so flexible that it can be built in many ways, and I try to make it clean, because this is still readable. It's much code, but it is still readable for that amount of possibilities. But there is not only this, because there is just clack, kick, and hi-hat that's not always playing, but this is hi-hat, and even there is this yeah, I don't have much control over this synthesis for now, but it's easily done, and we can explore this now. But keep in mind that it's not ideal, and it gets out of sync kinda, and yeah, it's not easy to think about now. And that's because we have these sequencers that are run by elementary, and they don't have enough information, so I cannot implement the progress bar with that. So I don't know in which point of this sequence we are, so I just don't see these indications. And the idea is that, yeah, I even have this saved here. So the author of this library, Nick, hi if you're watching, he told me how to do this with EL time. And let's explore this thing now, because it's just the recent thing. Because yeah, here in sequencer we still have these params, that don't control anything now, because the drums and clap synth are just there. So I borrowed them from Nick too, but they're not too complex, so I want to rebuild them with object parameters, not just a list of parameters. But I'm thinking about considering this. Yeah, and then we have this use sequencer that's using the kick synth, and these are just baked in these parameters. I don't control them because I'm just getting there. And to get there, I'm building this time section. And let's look at this, and maybe it's kind of very low level, but I like to have this solid foundation for further developments. And yeah, so LM time is just a regular component that is mounted by LM audio, some LM time here. That's why this loads, and we use time. So 2 lines of code in this component, not too much going on. So that's much for those 2 lines, and also 2 just groups of elements, HTML elements. And these are the params of so these are group, let's say, in time. So time, what is time? Let's look at this. And time is computed object entries. So let's see what is time. Let's put it right there. Time. So measures, BPM, time, beats, steps. So all these are listed, and these are these are meters that have names starting with time, and we just have them, and we have the title and have the max number from them. So this is our meters. Then we have these nodes that do all the work here, and I'll just show it in a bit. So time is the computed. That's just outputting all the meters that have time prefix, and yeah, it just shows them, and we can react to this list and display them, and not only display these numbers but make use of them. But let's see how they are constructed to understand which of them do what and how it's all working. Okay, so the basic idea is that we can have this EL time. So time is this. Time is just the number of samples elapsed from the time where we open the page. It kind of grows very big and very fast, but yeah, we can just then divide it by the sample rate. So oh, here's the sample rate, and I can go and take it from use audio, so we can just move it, because I believe I've seen it here in yes, in here. So let's say this sample rate can be time sample rate, and here it will be just el dot sr, a little, and we can just put 0 here. Yeah, we don't need this here because we have time here. But this sample rate is needed. Yeah, okay. I will just stay in the loop with time. Okay, this is not the thing that we just need by now. Yeah, okay. So time, use time. Let's close everything. Then we just divide by the sample rate, which is 48,000 for this audio card, and we have the seconds elapsed. So seconds are these 23 seconds from just when I refresh this page. Then there is BPM that is derived from the CV. So just this, we just display what BPM we set with this knob, and it just immediately, but it's not immediate, but it's a bit softened, because yeah, if we just jump the number, it can be a little dampened. Okay, then we have BPS, so beats per second, just divided by 60. But yeah, I like it because it's very useful in next calculations, because we have seconds from here and we have beats per second, so we can have beats, and this is just multiplying seconds by BPS, and we have time beats. So this is the number of beats elapsed from the beginning of time. Next are steps, that are just the number of steps in a measure. So if I change this number of steps in the measure, the number of measures changes, because this is our measure, and that's where I think that I should start moving things out, because these are just the place where I stopped, because this is just verbose. This just shows every single step, because it's so hard to think about it. For me, it's just very difficult to think about this time domain in samples and beats and seconds, and keep all this in mind, and what to divide, what to multiply. Yeah, that gets kind of hard, but yeah, you can do this step by step, and showing all these steps is fine. But here we see that we just don't have this, just measures. But no, we have measures here. Yeah, measures elapsed, 10 measures to but we don't have beats still, and we will have beats. But okay, now we have this progress, and this is measure, like progress. So I will have like measure. Yeah. Yeah, measure, not progress, measure. And timer. Yeah, we don't use timer directly, but yeah, we use it in seconds and seconds. So multiply, so this can be just measure. So we watch the measure, and it will be still all running, and this is the main kind of thing for me now, because this shows me the time where these 16 steps just go and pass. And the last thing I want to is beat. Beat, will be, yeah, I will need to add this because it's just not used in other places. So beat will be module of bits and 1. So I will just need the fractional part of bits, and yeah, bit will be used here. So I will need it to have time beat. Yes, this. So this is the kind of progress inside one bit. So if I have a some kind of progress bar, so every single bit inside will have this progress. This can be useful. This can show us some things, and once it's inside of you know, it's not visualized, it's not updating your DOM, so it can be very fast, and in your audio realm every of these components, every of these numbers can be really useful. And for what? Okay, let's make some time more expressive here. And for this I want to create some progress bar, I think, and it should be SVG. I think it should be SVG. Yes, SVG with a view box of kinda 0, 0, and it will be width and height. So 100 and 20, like this. So this will have we will have an SVG here, and we will have a rectangle of so x will be 0, y will be 0. Now width will be just it will be controls. No, it will be time measure multiplied by the width. So let's set the width. Let's set it as a transport. It will be a reactive variable. No, reactive from view. Oh no. Yes, a reactive object with just width of 100, height of 20. So I will say that view box should be string literal, okay, with transport height and transport width. Yes, and this will mean that we can just multiply by width and set height to just transport height. Yeah, like this, and this should be working fine already. Yes, we have this progress going on, so we can just put bits there. Just the number, divide this width by the number of bits, and we will have the progress bar hitting our bits. Okay, let's do this. So on top of that we will have a group of bits. Yeah, that of bit group. No, it will be group of bits, so it will be easier to work with later with lines, just lines. Let's say group, yeah, line. Yes, just line. No, I will add more later. Yeah, let's say it's at beat. So I like to separate the v4 and the actual element. Okay, but yeah, okay. No, let's say it will be template. Template, yes. v4 in B in so it will be time beats, I believe, or how it param time. Yeah, controls. In of course it will be like time beats, and key will be B. So just like this, it won't output anything, but I will put line that will go so X. So it, yeah, we will, yeah, I will take it as a beat again, because we will transform it. Yeah. Now we will see lines. Okay, let's make lines first. So it will be x1 0, x1 x2 are 0, y1 is 0, y2 is transport height. Yeah, this is y2. And we will have a stroke red, like this. It hang up for a moment. Maybe because we have some errors there. It's invalid array length, render list, invalid array length. Okay, maybe the loop is not correct. So looping over, oh yeah, looping over, yeah, this time beats. No, we will have not this time beats, but it will be control. Okay, let's refresh this so it's not overloading. Okay, controls time beats. Yes, this is a number. This is just a number, and let's check if we have these lines there. So inspector, rectangle, beats, and no nothing here. Controls, time beats. But beats. No, I need steps. Of course, steps. This here are my groups listed, and in each of them we will have a line that will just have y2 set to, again, transport height. Yeah, like this. And these are there are all the lines. Yeah. And then I want to transform it because it's kind of more transparent way. So I will translate. Transform will be like, like this, and we will translate by x. That will be, so this will be 0, and this will be like b multiplied by by a transport width divided by this controls time steps. So this should be better. This doesn't show us the lines, but maybe they are just transparent. Let's see. Translate kind of works for us, but yeah, it just doesn't have any stroke. Red and stroke width is like 10. Yeah, the only thing is that we couldn't translate because with transform translate yeah, transform, yeah, this is the problem. Okay, and now with 1, yes, so we have our 16 bits and any number of bits that we set, and then we have this progress bar hitting them, boom 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 boom, like this. And yeah, you can use it for many applications, because this can be even circular or built in any way. Yeah, I like it. I really like it that it's growing and it's doing its job. And maybe it's too high, and we can just make it 10, make it maybe even 1 or even 5. Yeah, so, and the colors will be not red, but at least like 3, like like 99, or maybe E, yeah, like this. No, E is too much, but A maybe, yeah. So yeah, and this rectangle can be also has a fill of like 333. Okay, so yeah, that's how it works. And let's check the dark color scheme. Kind of works. Maybe it can be a little brighter. 555. Yeah, 555 works here either. Yeah, and maybe there can be just a stroke of 2.1, and stroke can be also AAA, and the stroke width can be the same, 0.2 from this perspective. We can pad that, so but at least if I have 1 pixel, oh yeah, that's running, but 0.2 pixels is just fine. Yeah, so it's kind of working now. There may be an rectangle that's like all encompassing, like this. So and this stroke can go there also. So this can be width and height set just as the transport we have, so without this measure, like there. Yeah, that looks quite fine. And let's have just a P1 around it, or M1 better, or M2. Yeah, and this can be rounded, but yeah, I won't do it right now. Okay, these are this is where we are going now. So I'm kind of working on this time section, and next step will be to create the pulse that will be hitting this and hitting some function, some at least oscillator, that will go right into this time tracked, because we can have this time running kind of as a metronome, and it can be useful, but I think that metronome will be maybe a little separated, but no, why? I think yes, I will save it for time, so time is nice thing for this. One thing I want to correct is here, so dark BG is dark 300k or 700, 700, like this, or maybe even 900. No, I want to be 500, no, 200. Okay, so second, everything is running, and now we can just start compacting this into something more easy to learn about. So these are the steps, and the progress just jumps around, and I don't like it. I would like to have more sync. And one more thing is that I want to start and stop. So despite this time growing every time, I want to have like a play, pause and stop buttons that will make this progress running. From this visual style I can just make one fun thing that I use in my metronome, that is here in the rhythm and a circle and a loop. There is this level color function that's outputting us the color. Okay, I'll find it, level color. That's just giving us the color of each step, and it takes I N A. Let's go and check it, and let's import it here. So how it's called, level color. So what it takes I, which is the number, n is the total number, is a current index number, alpha, saturation, lightness. And this means that we can have these beats, these lines, and can set stroke to be level color with just B, and again controls time steps. So this should make the colors so from red to red it will be equally divided and the colors will be shown. This means that we can go from there. And also the change in BPM should change the initial color that we are starting from, and this is implemented by having this step plus tempo pitch. So tempo pitch is one important thing. Let's look at it. Tempo pitch, yes. So we get this frequency pitch. So it will be like a float point number out of the hertz. So we can just go to frequency pitch again and see this just math. So we can use that, and again let's have it frequency pitch imported from this useful use-chromatone library. and then but no, we won't import it there. We will import it into time. So yeah, now we can have this pitch of our BPM. Yeah, so let's say, yeah, we have an so pitch is again a meter of what do we set here? We set here we will set there EL const. It will be EL const. With yeah, we watch controls that have BPM. So BPM is watched, and this will be constructed again from BPM. Okay, so this will have first a key that will be like time pitch, and value of so it will be time BPM, time BP, no, it will be just, yeah, CV time BPM. Okay, we just need to, yeah, we need to process this BPM. And value will be, yeah, so this will be frequency pitch that will that we will import. Okay, that will generate so the frequency is in hertz, it's beats per second, yeah, so beats per second, yeah, so BPS, so BPM divided by 60, yeah, so we will have controls again with time BPM divided by 60, I believe, yeah, and we will add the pitch here. Let's check it. So beat pitch, beat pitch. Okay, so what do we have here? Pitch. Yeah, pitch minus 92. Okay, this is fine. So BPM, beats per minute, beats per second. So it's 2 hertz. 2 hertz is minus 99 pitch. Kinda. Yes, it's fine that it's minus, because then we just take this to color realm, and that's fine, because now we have the I and the total number, and this is the same, but this will be just plus, and we will set it to level color. No, how it's done here? So step tempo pitch divided by 12 and multiplied. So the step plus tempo pitch divided by 12. Let's divide it by 12. Plus see, you know, so level color will take me from 0 to 1. Okay, that's kind of, I need to think about it more. Yeah, for now we are moving like this, and we even can set this rectangle to have the color of oh, not the stroke but the fill that will be determined by the not the B but time progress. Should be like this, yeah, time, because we here iterate over here over, yeah, time prompt fixed, yeah, this should go fine. Let's reload. It's still too red. Okay, but it's red at least. Time fill level color steps, no, level color that will we will see time progress and 1. Level color, yeah. Like this, multiply by 10, like this. No. I out of n, but time progress is 1 out of 1. Time measure. Time measure, yes. Now we have this color changing because now we're reaching different parts. Wow, yeah, start from red. This doesn't look very nice when this linear motion happens, but still, yeah, we can just discern visually where we are at what's the place of this moment in time. I hope you like this explorations, and yeah, this goes slower and slower when I get into territories that are kind of new to me, and I have to think all of the steps and think about all of the architecture of this, and have, you know, visual and interactive stuff out of reactive composition APIs, composables, but still have these composables very powerful and reusable as much as I can. So yeah, this is a huge work, and I just shared it with you. And so time is an ongoing project, but we've moved a bit, and I just briefly will show you the others that are the analysis. So these FFTs that are just output automatically, and these use FFT is just that simple. It's just reactive objects that reacts to this meter that's outputting us all the information that we need, because we have this sample rate computed from the meter. And then we have the data also is, yeah, so FFTs and meters, yes. So frequency we will have yeah, data. So this data will be the content of the FFT information. Then we will have this frequencies for all of them, and this is very useful to get the colors out of frequencies, and the total number of no, this is not, this is the values, the total values, because there are two, like real and imaginary FFT numbers, and we just combine them here with just math log2 with ABS. But this can be sqrt, yeah, from power of 2 of these. I believe this is just the same. Okay, and this happens to 2000 rectangles. So we output this data, so this will be very useful. These colors and these these colors and data will be very useful, and we use this. So we create an SVG with the width set by the FFT's length, and then we go through all of the total, all the totals, and have the x calculated as a log2. So we have the logarithmic scale for this. They are going smaller and smaller, but if we look at this just from the point of one oscillator, sorry, maybe too loud, and this is too low, yeah. So here you can just see these overtones, and it's robust, it's reactive, and even if it gets a little laggy, the sound is just perfect, because it's just in a separate thread, and elementary is dealing with it perfectly. I like to export this here so it can be more easy to analyze. Yeah, and this is FFT, and okay, there is scope that just goes through scopes from audio and just maps points to just render these points in a polyline in an SVG. So yeah, everything is vector, and it means that it can be quite slow and laggy on small on not that fast devices, but yeah, it works nice on almost any desktop computers, and then I will optimize it more and more. What else? Drums I've shown you, and yeah, I will work on it extensively, but I need to understand how to make this modular and fun to play with and versatile to build something more with this. And also there is this mic input that works horribly, because yeah, I can just allow this same mic, but you see this sound is horrible. I don't know what's happening, because it's very simple, you know. Yeah, we have to use audio. We have to create a stream from user media. We have this stream source from the context, and then we connect it to Node, and it should work fine, not too complex. And then we have this input, so mic in with channel 0, which is our mic by default, and then we have this gain for it, and which is controlling this knob, and then this input just goes here. It's just input, maybe and it goes like stereo signal with this scope mic that is used here. Yeah, and if it's open, we open. If it's closed, it's closed. So we have it. Yeah, so it works like this. But the sound is horrible, and I don't know what is the point of this. I hope guys from this Discord of Elementary will help me, or I will find the solution by myself. Yeah, so this is my huge exploration and experimentation on all this, and I then just hit this build button to make sure that everything builds fine. There is no kind of errors that will prevent me from having this running on the website, and then we will just deploy it to the main Chromatone website. Yeah, this is how it is. This was my introduction into elementary synth and how I'm building it. The overall structure of this goes like this, and yeah, finally we have this folders with some helpers and these drums, and yeah, we have many modules that will just scatter around this website and come into here as a transport, come into here as a, no, MIDI will be the same, but here will be not this regular synth from Tone.js playing, but we will just turn this off and turn this on and have wow, why is it so distorted? Because of this cutoff and Q. Yeah, it's beautiful. Yeah, and it moves quite smooth even when we have this computation going. Yeah, I think everything then will be just GPU accelerated small shaders that will be just very, very nice and fun to use, but still it is it is a path to go through, and yeah, I will go through it. And yeah, thank you for being here for that long time. Yeah, I was trying to show you all the concepts that I'm building on, and I'm saving it for myself, so I will be eager to find out what was it built previously just from this video. So if you're into music and want to stay in touch with visual tools and how I'm developing it in many ways, so subscribe to this channel and stay tuned. And yeah, see you in the next video. Bye.